Okay, we are going to work a problem about forces due to motion, and um, in this problem, they're going to give us an equation and kind of ask us to prove it. So the setup is you have a particle, and it has a charge, and it's moving at a certain speed, um, and it's moving it's moving perpendicular to a magnetic field. And so here's the setup. Here's can't see it. Why won't it focus? Okay, there we go. So you have the charge Q, and it's moving at the speed v there at the top, and there's a perpendicular force, which is, you can see the force. It's moving towards the centrifugal force, and we have a radius r. Okay, and it gives us this equation right here. It says momentum, um, and it gives us momentum at the speed of light, and it wants us to be able to prove that it's equal to charge times the field times the radius. Okay. And it wants us to prove that this equation works regardless of how fast this particle is moving. Okay, so there's the charge Q experiences perpendicular magnetic force, which we just showed, and so we have this equation right here. You have your magnetic force equals the charge times the velocity times the magnetic field, and the only force in this setup we're concerned with is the force of the magnetic field. So that's F net, and we use the momentum principle. F net equals difference in momentum with respect to time, and that equals this other equation that they gave us. We know that velocity is the difference in distance with respect to time, and so we can replace our velocity in our equation, and you have QB difference and distance with respect to time equals the change in momentum with respect to time. And so we can say, after we integrate these functions, that momentum equals the charge magnetic field distance, and the equation for momentum at high speeds is right here. Right, and so momentum equals this momentum equation at high speeds equals QBR, and that's the proof for the equation that they gave us in this formula.